It's great to be here. How many of you are familiar with OTOY and its products like Octane Render, LightStage, Urbach? Wonderful. A lot of you guys know what we're doing. I use GTC as sort of a marker to talk about where the industry is at. I have another talk that's very focused on GPU rendering, but ultimately, rendering as a service for media and experiences is a bigger thing than just the software stack and the tools. So as a company, OTOY really wants to help build whatever it takes to get us towards the holodeck. And the title of this talk was actually, talking about light fields and how that affects VR. What's interesting is after years of working on light fields capture and software, it was only 2 hours ago that I got to have my very first light field HMD experience with the Avant Glyph. So that was, a really fascinating experience to see sort of depth and convergence working correctly. And I think that this does portend the future of displays. Whether it's going to be a TV with full light field system in there that can project all the rays, just basically like a holographic part of the holodeck, or something that goes into an HMD like this. That's the future. So for us as a company, whether we're dealing with capture or the software and editing stack or games or the publishing pieces, the end result's probably going to be something like a holographic surface. And this weekend, Tim Sweeney posted this question about what would be this ideal programming language if it was purely efficient, could run at infinite computing power. And my answer to that, among the many that posted, was that you would basically have something like magic, where your brain is driving the input, and your thoughts are converted into this creative, realistic output, and there is this feedback loop. So when you look at what's going to happen in the 2020s, you're of course going to want to have photorealism because that is necessary, even have synthetic and the real world match. Everything's got to be in real time, just because the display itself is a real-time display that changes at the very least with your point of view, but possibly because of incoming lighting and 6DoF and all these other things that can be merged with something that's traditionally been thought of as linear media. And it'll be intuitive as far as the authoring and content goes, and that means things more like tilt brush, or essentially tilt brush is like a magic wand. Those kinds of tools are going to replace, I think, a lot of legacy workflows. There are a lot of challenges, though, when you're dealing with getting this thing out into people's tool chains and also into their glasses. So we're working with a company called OTOY, the amazing AR glasses, about $1,000, and they have 2K in each eye, but the FOV is small enough that you really are dealing with about 16 times the resolution of the same density versus the same density on the Gear VR. And we're dealing with that trend going into this year, next year. So by the time we even get to next year, you're going to see 6DoF position tracking, 10 degrees of field of view, again, 6K per 90 degree FOV, and you're going to probably want to have really good pass-through. So I think that that's going to happen very soon, and there's a lot of challenges with that. Rendering and warping and even foveated rendering just are the tip of the iceberg of the things that you need to solve to get all this to work well. Our mission is to build, again, the software stack in places where there's efficiency barriers, and that started off with us actually on the capture side, but there's also just a lot of workflows that are very hard for people to wrap their heads around in terms of dealing with a lot of the data, trillions of rays versus megapixels when you're thinking about holographic rendering, workflow, delivery. So we've split the problem as a company into 3 different silos. And these all do converge, as you guys will see by the end of the presentation, but we actually started early on with trying to solve ground truth holographic capture. And LightStage has been a service that's done that for a very long time, and it's been doing it very successfully. We won an Academy Award for an avatar, and LightStage is actually still used today for things like movies where you need digital doubles or you need to recreate an actor. So the actor that was actually the stand-in for Tarkin and the actress for Leia used, LightStage datasets were used to drive that. If the Smithsonian needs to scan in the president, we actually built a portable LightStage and scanned in that was our first portable LightStage scan of a public figure. And the data sets themselves, when you're bringing that into the tool chains that we support, it's awesome. You just have absolute perfect fidelity, not just of the details and the depth and the contours, but also, more importantly, a lot of the relighting information. This year, just recently, Epic released a data set for Virtual Human based on our LightStage scan. So we're seeing a lot of game engines look at this data as a starting point for building realistic humans and avatars, and that is fundamentally important to the workflow of the future. When we're talking about a full LightStage scan, it's actually the equivalent of an 8D light field. It means you can actually take, for example, that fisheye lens at the bottom, and that's what's driving that render. This is a render, not a photo. And that was where LightStage began, was just basically having ground truth relighting. But we've also taken it further. We've increased the resolution. This is sort of a few years ago on vision research cameras. We were able to get absolutely super high fidelity. And more recently, off-the-shelf cameras, this is just 2 lenses. We're able to actually take data with an off-the-shelf system at 120 frames a second, and then give you an asset that you can then bring into a game engine like Unreal or Unity. And you can see here, relighting is still preserved. So getting this to be consumer-friendly is very important to us. And as we do that, as you start to see LightStage capture with inside of cameras and prosumer devices, you'll start to get really high-quality terrain, scene, object, even material capture becomes possible. And Orbex is our interchange format. I'll talk about that in a little bit. That's what we want to capture into. It is essentially the SVG or the PDF of the real world. It describes everything you would need to give a realistic experience, let's say. And as artists use our tools to scan in plants and leaves and assemble them in the rest of our pipeline, you end up with absolutely amazing synthetic scenes. This was done 2 years ago for the Oculus contest with our tools, and it was using a little bit of photogrammetry, which we can significantly improve with LightStage being in in cameras, on cell phones, but all the way to. And it's important that we also think about holistically just capturing environments in one go. So we've been supporting, with a free set of tools, we're working on getting RGBZ capture with a depth sensor. And it's cool, it's experimental, but it's something we're playing with. The other thing that is much higher quality is just getting a bunch of views, a bunch of cameras. This is GoPro lenses together, and then you can basically get a light field capture. And we did that test. We did it actually just for static environment, but just spinning a camera around. And the end result of that is you can build a holographic volume about 1 meter around that you can look inside of, and it's really cool. The thing is, we want to get this working for video. We'd actually shared some of that early research with a group at Facebook led by Brian Cabral, who's now 2 generations into their Facebook 6DoF camera. And we actually worked with them on building a whole pipeline around their new camera system. And we're providing a big part of the cloud pipeline, the ecosystem. I mean, we're basically taking the data from their cameras, spitting out an Orbex file that you can drop into about 30 different tools, which we have plugins for. And the end result is you can then publish that to your Facebook newsfeed, potentially other devices. And the workflow tools that we're now supporting include things like After Effects and Nuke and Unity. And these things are not traditional 3D tools. They're video tools, or in the case of, but it's very important that we introduce those basic concepts around light field rendering and physically correct rendering in those workflows so that you can take, for example, that Facebook camera data, bring it into Nuke, drop in synthetic objects that are either captured or from, let's say, the Unity asset store. It doesn't matter. These things all now can be interchanged through our pipeline. And you can start to really get a sense of how you can think about workflows, even if it's linear content that's volumetric. We deliver that system, and it works really well. And in Unity, you can actually add game elements, which is what we're doing here. This is the Facebook camera data being fed through Unity with point lights, and then you can take it even a step further. This is me giving it. This is actually at the GTC demo booth. I'm using the touch controller as a real-time spotlight, and I'm relighting the live as I'm in the VR experience, and that probably is a good indicator of the kinds of minimum viable video experiences we'll be having in a few years. So getting to that to work is not just about capture. Rendering is fundamentally important. That's where Octane Render comes in. It's a GPU path tracer. It's basically, I call it RenderMan or Pixar in a box, a laptop or a couple of GPUs, and you can do the opening of Westworld, which was done by Elastic in our Cinema 4D plugin. And you can see Octane's beautiful. I mean, it absolutely is. It's like the laws of physics. There's no faking it. It's an unbiased render. And getting this kind of technology to work across all these different ecosystems means we needed an internet, and that's where Orbex comes in. If you see here, if you do view source and a bounding box in any of the tools that Octane's in, you can use this node system to mess around with it. And now we have, we're approaching 30 different plugins that can do this, including Photoshop and game engines. And there's a lot of the parts of the cinematic toolchain that just haven't been exposed. Photoshop, you can bring in OpenVDB volumes, and we have now with game engine support, we see Unity as a fundamental entry point for Octane for our entire pipeline. And it was a big decision for us to make Octane free. It's a few $100, but now it's going to be free and in the hands of nearly 7 million artists, starting with Unity 2017. We won't hold any features back. We're just going to basically save the paid subscription above that for extra tools and services. But inside of Unity, you'll be able to actually generate and bake light fields, bring those things in, connect to other tool chains like like After Effects or Nuke, and that's super powerful. So when you look at something that was done in inside of Octane, similar to the what you saw with the opening of Westworld. Like, this is a beautiful scene. Most people look at this and they don't even think, they wonder, is it filmed? No, it's all completely done by one artist, one of the greatest artists I work with in Spain at BLR. And we can just take that scene from Max and just drop it into Unity. And all of the Octane plugins basically export in Urbach, so the scene into the Unity editor. This is running on my laptop. I can drop in the OpenVDB file volume. I can take the Atom demo, which is Unity's high-end cinematic VR system. I can take things from the asset store and drop it in there. And guess what? Everything is rendered correctly. There's a little bit of noise. It's like taking a Polaroid snapshot, but it's very fast. I mean, there is no render time. It's just, it takes a few seconds. And we've applied this to doing, cartoons. You can now basically, this is a Batman the Animated Series, attributed for Mattel and Warner Brothers. But what's cool is that even in Unity, if you just drop in a Unity asset, it just gets automatically converted into Octane quality. That includes the lights and even Unity fog. And what's also interesting is that Unity, our integration, gives you this idea of proxy. So if you have something like this hallway, which actually has fog and all these other elements in there, it just shows up as a bounding box inside of Unity. But in the Octane viewport, which is also in Unity, you can see what the fog looks like. You get all those features in there. And as we started to integrate Octane with Unity, we've started to make changes to Octane itself. You now have all one system, the Urbach node editor. It's built into Unity, and that means everyone can connect and use that node graph and connect that to other pieces. We've also done extra work around basically supporting FBX and the emerging GLTF standard, also in Urbach, which is critical for doing real-time character animation in path trace viewport. We're adding inside of the ray tracing inside of Unity and any of the Octane tools, you can now move things around, critically important. And there's also the idea of being able to render to texture. That's something that's very common in Unity. We've now added that into Octane, so you can use that to great effect inside of all sorts of weird interactive workflows that might be more suitable for games. And secondly, we started by supporting all of the Unity natives, but now we have an API where people can build all sorts of crazy procedural geometry that goes way beyond what you could do in the rasterized viewport. We've most recently used this to get vector displacement maps, which are really at the very high end of cinematic tools. All of this will work in Unity. And we're also working with Unity and others to support open shader, which is the industry standard. It's used now in RenderMan and many others, and it's able to ingest pretty much, you can drop in shader code from the web page and you can drop it into Octane and it'll give you procedural textures in real time, and it's awesome. And Octane is basically turning into a compiler for different languages designed for rendering, which is kind of necessary for these kinds of novel work. The last bit we're putting into Unity, and this will also be in Unreal, is baking. So baking is something that is not great inside of Lightmass or Enlighten or these existing frameworks. And the free version of Octane in Unity will allow you to turn your Urbach scene into a mesh up to 10 million polys, and it'll bake it, and it'll actually bake a an animated mesh that can be played on a PC, and it'll look great. The problem is meshes don't necessarily cover everything. You need to have, baking needs to cover things like real-time dynamic ambient occlusion. So this is actually a new layer that we're adding inside of Octane. It's called Octane Imager, and it deals with post-processing. And it basically is doing real-time ambient occlusion, real-time reflections, and denoising at the same time. And it's very close to the Octane ray tracing pipeline, but it is designed for essentially real-time viewing. And to that end, we're also adding other filters in Imager that are dealing with deep learning, denoising. We talked a little bit about that in our last presentation, but we do see AI and deep learning neural networks as a fundamental part to get you the highest quality. But ultimately, if you don't want to use any tricks, the next version of Octane will solve one of those problems, which is if we just want to render all the rays, not bake into anything else, and just deliver you the ultimate dynamic scene, Octane 4 is designed to do that. This is basically an experimental version of our Brigade path tracer. We're merging those together into Octane 4, and we're also looking at in hardware. Like ray tracing ASIC by PowerVR is 10 times faster than doing it on the GPU, and that changes the entire equation for us. That means that one GPU built on this hardware at 120 watts could do 6 billion rays, and that means that Octane would run in real time with no noise. The other workflow enhancements we're building is Octane as a service, so you can basically take a WebSocket and with your Octane subscription build any sort of front end you want in the web or in WebVR. We have a cloud service where you can essentially send any job that is too expensive to run on your computer to the cloud. It'll deliver that to you for a fairly reasonable cost. And then we're also just introducing a subscription layer that includes pretty much all the basic tools you need to use Octane and integration, not just Unity, but Unreal Engine, Adobe After Effects, Nuke, Autodesk 360, plus an additional plugin of your choice. So with all those in place, the last bit of the pipeline is how do you deliver these experiences? How do you get all this to run and get into devices today? And it's not just HMDs, it's possibly phones, and phone AR is a big deal. So we came up with a representation of an Orbex scene file, and we have built a media player, Pure Lua, and that's Orbex Media Player, and that's totally open source. We share that code with Samsung and Oculus and others. But the idea of Orbex is that if you don't want to run Octane or you can't run Octane, let's take all of that quality and bake that into a holographic surface, and that's what we call light field rendering. And so you have these holographic. That's what we started with a few years ago. Today, inside of Unity, you can basically take a bounding volume and you can get a true light filled cube. And this is so fast that we can actually stream that off of the disk. This is actually, each cube is moving through time and space. They connect with each other. You essentially have the 6 walls of the holodeck, in this representation, and we can publish that to phones and other thin devices. And that's what we're showing here. This is showing a sliced view into a light field that's published on the cloud through phone-based AR. And this is showing an object, light field, scanned in on LightStage, run through Octane, and then streaming back onto a phone with a marker. Built support for this on Project Tango, and all these things launch from a link on a web page. So there's no app, you don't need to build an app to get all these to work. We want this to run in WebVR or WebXR, whatever they want to call it. And Orbex JavaScript is our take on that. We also have the Lua version in tandem to get you the best performance. And this is probably the best stream we've seen, which is on the was always been a huge supporter of what we're doing, gave us the concept of looking at the predictive packets that he has, so we know in advance where you're going to be looking, and we can then beamform the light field in there. And we're sending that depth and other transparency layers, which gives you, positional time warping on the local system with multiple views, and that gives you most of what you need. Perspective. This is basically, we haven't shown this until very recently. This is the Unity editor taking that very same light field stream and showing how you can attach anything you want to this. And you can then republish that as a WebVR experience or put it back in an Orbex file, which we can support inside of Orbex Player. So Orbex files themselves are we have we now have perfect support inside of probably one of the biggest web browsers on the, in the VR space, Samsung Internet. This is loading an Orbex scene, and you saw there that you actually had a web page in there that was relighting the scene. So you have a lot of the relighting system inside of Octane Imager in Orbex media files. And what we've done even more recently is you can take your entire Unity interactive layers, the C# code, all of that, and drop that into an Orbex file. And you don't need to publish a Unity app. You can actually mix those together, and it's very powerful. So you can see here the Unity application is in the Orbex, working essentially as a live stream and relighting it. So we can actually have a Unity app that includes Orbex. We can publish an Orbex file that can be read by a browser that includes native Unity support. And as we even support just Facebook, which is one of our biggest partners, there's all these different workflows that our cloud service, spits out. Even if it's for somewhat linear content, you have the ability for all of these files to be ingested by Facebook's existing 360 API, whether it's an MP4. The very same link, Facebook can, a link can bootstrap a 6DoF experience inside of Samsung Internet or Orbex Media Player, and on the desktop we actually have a simple WebSocket proxy that boots it up into the Rift or the Vive, and it works really well. So our steps forward are trying to come up with ways of getting all of this work to be used in open standards, and we've been very lucky. We've worked with the JPEG Plano group and the MPEG-I Lightfield group to get Orbex ingested in there. We're going to be making an effort around that in July in the next MPEG meeting. And I certainly think that if Orbex itself isn't ingested into these standards, it's a good framework for what should be in there. And with that, I think that an open metaverse and all of these we see coming, both for artists, creators, and consumers, are likely to happen in the next few years. And the 2020s are going to be insanely exciting for all of us. So I think we have about a minute for questions. Thank you very much for listening, and I hope you guys enjoyed it.
Thank you. Does anyone has any questions?
I think we have a question in the front here.
So could you, I'm particularly interested in how you're turning your light field something that you can manipulate in Unity, and so you're going from you're dropping your Facebook 360 point was it your light field from your Facebook camera, and then you're dropping that into a game engine and you're making it And just maybe, like, I know you went over the workflow, but could you maybe just like,
So it's very simple. The Orbex media player piece that you saw, you can go back to a couple of slides here, which shows exactly how this works. We basically fill in, we have a texture ingestion pipeline, and even in Unity Editor or in Unity Games, you can create a proxy or a box or a sphere, and we fill that in with the correct data. And it could actually use the Unity displacement to give you a point cloud, or we can handle the entire rendering and just have Unity drive the scene graph. But it's bidirectional.
so when you have an object that's captured by, you're defining a square around a point cloud, is there?
Or a box. A box would be, it's more a volume than anything else. So the traditional system is going to be all based around bounding box volumes, and that's something that you literally see as a bounded box in Unity until we render it in Octane, or we render it with the Orbex representation of that. And if you wanted to composite with Unity assets, we can handle the compositing, or we can turn it into a voxelized displaced mesh in Unity, up to a certain limit. But both of those are options that we let.
When you shine a light on that cloud, and you're running calculations on how each of those points are changing?
Yeah, so we have inside of the light field viewer, it's an 8D light field system, so it can take direct light, it can take indirect light, it can as it's rendering and ray tracing, it can do bounce reflections. That is in our compositing workflow. So if you want all that stuff, if you really want to blend things together, you probably want Unity to be running in the Orbex presentation graph, which is typically how we think most experiences are going to work. And if you really want, you can feed that back into the Unity engine as in the screen space effects system. So but yeah, we do relighting actually per frame in real time using a combination of ray tracing of the light fields and other techniques that are basically